My dear student, how are you? I think all of you are well. Today I am going to conduct another class. So welcome to Amader Pathshala presented by Manipur Uccha Vidyalaya and College. Before going to my main lecture, I would like to draw your kind attention to my previous lecture. What was my previous lecture? My dear student, can you bear in mind? My last class was the lecture number 4, and in this lecture, I told about the combination of cells that is already shown in the projection. This is the series combination of so many cells, and this is the mixed combination of cells. In this lecture, you have learnt about how to calculate electromotive force for the combination of cells and what will be the current of this mixed circuit. So, my dear student, you already have guessed what we are going to learn. Today, I am going to learn another class on this chapter. So, welcome to my today's topics. My today's topics: shunt, galvanometer and ammeter. Chapter 3, current electricity, lecture 4, and this is the last lecture of this chapter. Physics second paper for class 11 and 12. So, what is the learning outcomes? At the end of the lecture, the student will be able to know what is galvanometer, difference between galvanometer and ammeter, how to connect ammeter and voltmeter in the circuit, how can you increase the range of ammeter or voltmeter, and finally, you are able to solve mathematical problems for the exam. So, my dear student, my today's topics, I again repeat, shunt. You know that this is a resistance having a low in magnitude, that is low resistance. So, I start my lecture with the definition of shunt. What is shunt? A low resistance which is used in parallel with a galvanometer so that high current does not pass through the galvanometer and cannot damage it is called shunt. From this definition, it is clear to you that shunt is nothing but a low resistance which is used in galvanometer so that galvanometer cannot be damaged, and it is also connected in parallel combination. So, this is also resistance and which is connected in galvanometer. So, another new thing for you, that is galvanometer. Have you heard the name galvanometer? I think all of you have heard the name galvanometer. This is a device which is used to measure and the existence of current in a circuit. In this galvanometer, we just use shunt. So, is there any uses of shunt? Of course, another uses of shunt are ammeter and voltmeter. So, what is ammeter? Ammeter is another instrument by which current in a circuit can be measured directly in ampere unit, where we also use shunt. And it is also connected in series combination with the circuit, in series with the circuit, in the circuit. Now, the galvanometer and ammeter, or these two devices are same. In order to know this question, you have to keep your eye in my today's lecture up to the end. Now, I am going to discuss about the application of shunt in galvanometer, which also I mentioned in the definition of shunt. You know that shunt is a resistance which is connected in series in parallel with the galvanometer. So, there must be the division of current among the between the galvanometer and the shunt. This is a galvanometer having a resistance Z and a small resistance shunt which is connected in parallel with the galvanometer. So you can easily guess, if the circuit current is I, at this point A, this current will be divided into two portions, that is Ig, galvanometer current, and another one is shunt current. And these two current at point B again makes the main current I. So this is nothing but the energy conservation. Then you can write I equals to Ig plus Is. That is main current equals to galvanometer current plus shunt current. Now I am going to establish the relation between galvanometer current and shunt current with the resistance of galvanometer Z and shunt. This is the same figure again, I repeat here. In this case, this is the A point and this is the B point. If the potential at point A is VA and the potential at point B is VB, then simply using Ohm's law you can write VA minus VB equals to Ig into Z, where Z is the resistance, galvanometer resistance, and VA minus VB is the potential difference. The same formula you can apply for the case of shunt. Then you can write VA minus VB equals to Is into S, where Is the amount of flowing current through the shunt and S is the resistance of shunt. You know that this is a resistance, but its symbol is S and nothing else. If you observe these two equations clearly, you will see that the left hand side of these two equations are similar or equals, but the right sides are different. Then from these two equations, you can write Ig equals to ISS. Then rewriting this equation, you can write Ig divided Is equals to S by Z. Now to establish the relation between Ig and Is, just we add 1 in both sides of this equation. Now adding 1 on both sides of this equation, you can write this. Here Is is the LCM and Z is the also LCM. Then simply using mathematics you can write Ig plus Is divided Is equals to Z plus S by Z. And you know that Ig plus Is, this is the total current. Then you can write I by Is equals to Z by S. From this equation you can write Is equals to Ig Z plus S. So this is the equation of shunt current relating the relation between galvanometer resistance, shunt resistance and main current. Putting the value of Is in my previous equation, you can find the value of Ig, and this is the equation for Ig. This is the galvanometer current. So my dear student, we have already found two equations relating to the main current with the galvanometer current and the shunt current. Now from this equation you can write I equals to Ig Z plus S by S. This is a factor Z plus S by S which is multiplied with the galvanometer current. This factor Z plus S by S is called multiplier. This is the shunt multiplier. So what is shunt multiplier here? Z plus S by S. This is a mathematical equation of shunt of multiplier, multiplier of shunt. So what basically the definition of multiplier of shunt? Shunt multiplier is a function through which the multiplication of galvanometer current you will get the main current. That is, by multiplying galvanometer current with the shunt multiplier you will get main current. So you have learned two more equations. Now do some mathematical problems related to this equation. So this is a mathematical equation for you. This is a galvanometer having resistance 100 ohm, can measure up to 10 milliampere of current when flow safely. To measure 10 ampere current, what resistance of shunt needs to be used? That means you have to calculate the amount of shunt, that is magnitude of shunt. So what are the given variables here? Number one, the given variables, the resistance of the galvanometer G equals to 100 ohm and galvanometer current Ig equals to 10 milliampere, which can be written 10 into 10 to the power minus 3 ampere. Then another given that the main current I equals to 10 ampere and you have to calculate shunt resistance S. Then you know Ig equals to Is, S plus G. If you take cross multiplication, then you can write finally S equals to Igg divided by I minus Ig. This is a simple mathematical equation. You can write from this equation. Putting the value of Ig, G, I and Ig, you will get 0.1 ohm. So this is the shunt resistance or the value of the shunt. My dear student, just I have solved a simple mathematical problems related to galvanometer current, through which we have learned how to calculate the shunt resistance. Now another application of shunt, that means how can we convert a galvanometer into ammeter or galvanometer into voltmeter. Now first I draw your kind attention to the first fact, that is how can you convert a galvanometer into ammeter. That is the use of shunt, and this is simply a galvanometer. You know that galvanometer contains a magnet and a moving coil. This is a moving coil galvanometer where the rotation, where the deflection of the coil is measured by the rotation of the pointer, and this pointer is connected with the coil so that the deflection of coil is shown by the indicator, and this indicator is calibrated along a ampere scale. Then this device becomes a ampere meter or simply ammeter. That is, galvanometer is converted to ammeter. Now you know that the galvanometer is connected with the series of the circuit. So the resistance of galvanometer may affect the resistance of the circuit. That's why we add a small resistance shunt with the galvanometer in parallel combination, so that the equivalent resistance with the circuit remain the unchanged. That means there is no effect of equivalent resistance in the circuit. Then what will be the value of shunt? In order to calculate this, we have to see our previous slide, that is Ig equals to Is, S plus G. Then you can write simply by cross multiplication and changing sides, you can write S equals to Igg divided I minus Ig. So this is the required value for shunt in order to convert a galvanometer into ammeter, and this is the calculation of shunt. Now this galvanometer is converted to ammeter when this amount of shunt is added with the parallel combination of the galvanometer coil, but this ammeter can measure a limited amount of current. That is, it has a fixed amount of current that can measure, that is maximum amount of current it can measure. In order to measure huge amount of current, we have to increase its range. So what is range? That is, I am going to tell about how to increase the range of ammeter. Is it clear to you what is range? That means a ammeter that can measure a small amount of current is to be converted an ammeter that can measure huge amount of current. This is the range. That is, in order to measure the desired amount of current, we have to change the range of the ammeter. In order to do this, we just have to arrange another resistance with the parallel combination of the ammeter. You know that in this case, I just mentioned now galvanometer, this is simply a ammeter, and whose internal resistance is R. You know that this internal resistance comes from the galvanometer resistance and the shunt resistance that I have told in my previous slide. And this is the ammeter that can measure I amount of current. But in this case, you want to measure n times of the current, that is n times more current. To measure this, you have to add a small resistance with the shunt. So in this case, what will happen? This is the amount of current Ni, this is the desired current, and this portion A will be totally divided into two portions, and this ammeter can measure only I amount of current, and the last amount of current Ni minus 1, this is the rest amount of current, and this rest amount of current will pass through the shunt. You know that shunt is a small amount of resistance, so maximum current will pass through this way. Then from these 2 points you can using also Ohm's law. So you know that Ohm's law is very important for you, and now simply using Ohm's law for the case of ammeter you can write VA minus VB equals to IR. This is the flow of current and this is the resistance of ammeter, and this is the potential difference. And for the shunt you can write VA minus VB equals to Ni minus I into S. So this is the same equation as I studied at the beginning of my lecture. So in this case also the left side is equals, then right side will be equals. Then you can write, in this case again the left side VA minus VB and also VA minus VB. So left side of these two equation is equal. That means right side will also be equal. That is IR equals to Ni minus I into S. Nothing but I have write in this. This from these two equation we have write IR equals to Ni minus I into S. And from this equation if you take common portion I, then cancel I from both sides, that is I and I. If you take common I from this equation, then you can write R equals to N minus 1 into S. Then you can arrange this S equals to R by N minus 1. So this is the amount of shunt that you have to connect parallel with the ammeter to make large amount of current, that is N times of current. Now do some mathematical problems related how to increase the range of the ammeter. This is the internal resistance of a ammeter of 2 ohm. It can measure up to 0.2 ampere current. What step is to be taken has to be taken to measure 2 ampere current. That is, my dear student, here this ammeter can measure 0.2 ampere current, but you have to convert this ammeter to ampere current. So what will be the range? This is the desired current and this is the maximum current the ampere can measure. So from this two is the vital portion to solve the mathematical problems. Now what are the given quantities? Number 1, the internal resistance of the ammeter R equals to 2 ohm. This is the internal resistance and it can measure maximum amount of current, that is I. This is the desired current 2 ampere, and the current it can measure I equals to 0.2 ampere, and you have to add step. What step has to be taken? That means you have to connect a shunt resistance. So you have to calculate shunt resistance S equals to what? Now the solution is here. First of all you have to calculate the range. This is the desired current, the maximum current, and the current that the ammeter can flow, that is 2 ohm divided by 0.2, and that gives 10. So you have to arrange a ammeter that can measure 10 times more current. So now the formula is S equals to R by N minus 1. Putting the value of R and N, you will get 2 ohm. This is the internal resistance and this is the N times current, and in this case this is the 10 and simply 1 by simply mathematics 2 ohm by 9 you will get 0.22 ohm. So this is the desired shunt that you have to calculate 10 times more current in the circuit. Now my dear students, I mentioned two things. One is how to convert a galvanometer into ammeter, and second one how to convert a voltmeter into galvanometer into voltmeter. Now I am going to discuss this. This is a voltmeter and you know that this is a galvanometer. Again it contains a coil and the magnet, and this is the moving coil galvanometer. There is also pointer which is moved along scale, calibrated scale, graduated scale in volt, and this scale is compared with a standard unit. You know this. You know that this voltmeter basically measures the potential difference between 2 points of a circuit in volt units. You know that this voltmeter is connected in parallel combination with the circuit, and the galvanometer contains a low amount of resistance. So, galvanometer can flow few amount of current, which make our total calculation problematic. That means this low resistance can be added to the circuit, which may affect our calculation. That is why we connected resistance R, which is bigger in magnitude, with the series combination with the galvanometer, so that if any current pass through the galvanometer due to huge amount of resistance, more current will not flow through the galvanometer. On the other hand, this galvanometer and this combination is connected in parallel with the circuit, so that does not affect the equivalent resistance of the circuit. So this is the better combination, and when this is done, this galvanometer basically converted to voltmeter, by which you can measure the potential difference between 2 points of a circuit. So what will be the calculation of R? We know so many things, the importance of the large amount of resistance, but we do not know what will be the value of this resistance. Now, just calculating this. And for this simple case, you can write I is equals to R plus G equals to V. You know that these and this resistance are in series combination. So, this gives the equivalent resistance, and this is the following current through the galvanometer, and this is the potential difference. Then you can write R plus G equals to V by Ig, and simply R equals to V by Ig plus G gives the minus G. So this is the equation for calculating resistance, which is to be connected with the galvanometer in order to convert this in voltmeter. So this is the equation. Now the same case I repeat here, this galvanometer or this voltmeter can measure the limited amount of potential difference, but I want to use this voltmeter to measure huge amount of potential difference. In this case, I have also to increase the range of the voltmeter. How to increase the range of the voltmeter? This is the voltmeter. In this case, we have also taken another large amount of resistance with the series combination of the voltmeter, so that equivalent resistance of the circuit remain constant, and this is the resistance. In this case, when this amount can measure only V amount of potential difference, then you can write V equals to IGR when no resistance is available here. This is the equation when there is no resistance R, then you can write this, and when you add this resistance, then this equation will be in this format. This is the N times, this is the N times. You can measure without adding R, this can measure only V amount of potential difference, but when you connect this resistance in the series with the voltmeter, this can measure NV times NV, that is N times of potential difference. In this case, equation becomes Ig R plus R. Now, this equation you can write R plus R equals to NV divided by Ig, then R becomes N minus 1 into R, because N equals to, you know that, I by Ig. So this is the equation in order to increase the range of the voltmeter. So there is a great similarities. In this case, the resistance is denoted by R, and for the ammeter you have denoted this resistance is shunt. Now solve a simple mathematical problems related to this. This is a galvanometer having resistance 15 volt, having potential difference 15 volt, and having resistance 1000 ohm. Now you want to measure 150 volt. Then what step has to be taken? That means you have to increase the range of the galvanometer. So what are the given or the information here? Number one, the resistance of the galvanometer. In this case, this resistance is denoted by a smaller like the ammeter, that is 1000 ohm. And second one, the maximum potential difference, that is 150 volt, that you have to measure. And third one, the core resistance R, that is you have to calculate. In order to measure 150 volt, you have to add R amount of resistance. Now, first you have to think the range. This is the range for the galvanometer, and this is also tense. Considering unfortunately these two ranges are the same as we have done for the ammeter. And now, using simple formula, R equals to n minus 1 equals to R, putting the value of n and small r, you will get 9,000 ohm. So, you can guess what a large amount of resistance is to be connected with the voltmeter in order to measure 10 times of potential difference. So, my dear student, in my today's lecture, I have told about what is shunt and then what is galvanometer and how galvanometer can be converted to ammeter and voltmeter. And also you have learned how to increase the range of ammeter and voltmeter. And finally, you have solved so many mathematical problems. So, as my previous, I am going to interested to give you a homework, and this is nothing but a creative question for you. This is a very important question. I think you can solve this problem. This is the resistance, and this is the ammeter, and these three resistance, and this is the electromotive force. So, what is shunt? Why voltmeter is to be connected in parallel combination with the circuit? You know that I have already told in my lecture. And find the reading of the ammeter. This is the ammeter. That means you have to calculate the main current of the circuit. And the last question is this: if the resistance of the ammeter is 100 ohm, then by taking what step you have to you can measure the available current in the circuit. That means in this case you have to increase the range of the ammeter. So, no more today. I think all you have enjoyed my class. No more today. Thanks all.